Hey, Darren here with Renaissance Coders. If you want to see more videos like this one, hit that like button and subscribe to the channel. The fancy YouTube algorithms will rank us higher and enable us to keep making great content for you. Thanks for your time. Now let's get into the video. Alright, so in this video I'm going to show you my complete development process. You'll get to see what I do to create or search for art, how I run into errors, and make design decisions quickly. I'll try to cut out anything that isn't useful to your learning, so just sit back, enjoy, and let's see how long it takes to build Flappy Bird. If you have an Android device, you can find and play this project right now on the Play Store. Just search Renaissance Coders, Flappy Bird. Okay, so first I'm going to start off by opening a couple resources that I know I'm going to need ahead of time. The first one being the Unity API. If I get stuck on a method call or something I don't remember, I can just do a quick reference to the API. Another thing is flaticon.com. This is what I use for my free art purposes, basically. I could just search something like bird, which is something I know I'm going to search for this project. And if I select selection up here, then I know that all of these are royalty-free assets that I can use. I just have to provide attribution to them in the game. So we'll come back to that, but I'll leave these open. Let's go ahead and create our new project. So I'm going to create a new project. I'm going to call it Flappy Bird. So it's not going to be called Flappy Bird, but Flappy Bird is okay for me. And then I'll set my initial project assets, or however Unity loads it, to 2D. And then I'll just select Create Project. And that's going to take a second to load up. And I'm going to provide a link to any of the resources I use in this tutorial. So if I'm using a piece of software that you're unfamiliar with, I'll provide a link to that with documentation and resources. So I'm going to start off by creating a few folders in my directory. Okay, let's go ahead and start off by saving the scene. So I'll say save scene, and I'll just drop this in as game. We're only going to have one scene in this project, and that's going to be game. So make sure I save that before I get any progress done. I'm also going to add in some fonts. So if you're using Windows, you can do this like this. You can just type fonts. And the two that I'm going to use are FFF Forward and Segoe UI. Segoe UI is kind of a big one, but I really like the way those look for general purposes. So that's going to take a second to import. So while that's importing, we can actually get into some art. I use Gimp for art. I don't use Photoshop. I know Photoshop is great, but I never took the time to actually learn it. And from what I can tell, I can do a lot of the same things in Gimp that people show me in Photoshop. So I'll provide a link to this, of course. There's a few assets that we need to make sure that we have, though. And I'm going to be creating several of these on 1920 by 1080 canvas. And that's just sort of a default landscape canvas. I know that this game is going to be in portrait mode, but I want to make sure that I'm covering that width on various aspect ratios. So my clouds, my background, my ground, and my stars are going to be on this size image. So I'm not going to go into too much detail as I create this art. But what I am doing is creating a gradient from sort of a light blue to a dark blue. And then that should be a good backdrop for our background for our game. And I'm going the opposite direction. I want the light to be on the bottom. I want it to be darker as it goes up. Okay, too much light there. It doesn't need to be perfect, and I don't want to spend too much time on the art. I'm going to export this directly into my project sprites folder. Okay, and this is going to be called background. And that'll take a little bit of time because there's a lot of color information. Looks like my fonts are still trying to be imported into Unity. So Segoe UI takes a little bit of time for sure. After background, we will work on the clouds and the stars. Those will both be pretty easy. I'm going to create those on a separate layer so that I can export those independently of the background. So the stars and the clouds are going to be parallaxed. That's why I want them to be separate images. So I'm going to use this brush and this stroke, and I'm going to use a little bit of a lighter color so it stands out. This should make it pop a little bit more. And I'll place these sort of pseudo randomly. Like I said, this is going to be parallaxed, so these are going to be reproduced over and over. It would be the same exact image, and I'll use a smaller stroke as well. Some smaller stars, maybe they're further back or something. Okay, I'm just randomly placing these, no method to the madness. And that looks good to me. Now let's create the clouds, and I'll actually go ahead and save this. I'll export that to stars. And then we can create the clouds next. So clouds will be pretty easy. I'll make, well, that's probably a good color for my clouds actually. I'm going to use this stroke and make it a little bit bigger. So I can just create a cloud, something like this. You know, just sort of silly, cartoony. Doesn't have to look exactly like a cloud, obviously. It's just a game. And I also don't want to spend too much time on these. It's really easy to spend a lot of time just perfecting the art, but we don't really have time to be doing that in this tutorial. And I'm sure a lot of you are more interested in the Unity development aspect as well. Okay, and this will also be an image that's just recycled over and over. And hopefully that's okay. I don't want it to be too busy, but like I said, I'm not going to spend too much time on clouds. Okay, after that, we also have the ground. The ground isn't going to be parallaxed in our case. So it doesn't need to have too much detail. It just needs to be like a gradient. And I'll create like a sort of dark cartoon outline. So I'll put a gradient inside this. So I'll do an intersect select, and then we should just see like a outline on the top of that. So I need to find some greens. I already have some here. We can go with something darker than that, I think. And I'll do a gradient. And this one needs to be straight. Especially if you're parallaxing the ground, this needs to be exactly the same. So it looks pretty straight to me. I know I said I'm not going to parallax the ground, but just in case you are, you need to make sure you do that. So this is what our scene is essentially going to be looking like. It's not too bad. I think I might want to erase some of those clouds. I feel like it's a little bit too busy. So here's what I'm going to do. I'm going to erase a couple of those. I'll erase that one and that one, or perhaps that one. And let me add, let me copy this one. So I'm just going to paste that and move it over here. So it looks good to me. So I think that's okay, and then I'll merge that down if I can. Looks like my layers are locked. But I'm just going to export those clouds again back to where they should be. And then since I created the ground, I'll export the ground as well. So export ground.png. Okay, so we have background clouds, ground, stars. I need pipes, and I'm going to need a different size image for that. So the pipes that the bird is flying through, I need to create those. And I'll set that to a width of 360 and a height of 2048. The large height is just to compensate for the pipes moving up and down on the screen. We just want to make sure that the player is never going to see the bottom of the pipe. So let's start off with a white background. And this should be the last piece of art that we're going to create. We'll find some other art on flat icon. So make sure this is on a new layer. And that looks like that font finally imported. Okay, I'll try to make this as center as possible. I know it's not going to be perfect. I'll use that sort of dark color background since this is going to be sort of cartoony. And let's give it a width of 8, perhaps. That looks good. All right, and I'll go with that same color green, I think. I think that works pretty well for this, that gradient. Gradients make anything look good, I think. It's hard to mess up something with gradient. Then we want to add some strokes on this to make it look a little bit nicer, I suppose you could say. We'll do 20 and 40, I think. I need that selection back, actually. So we'll go something like this. This won't be perfectly straight, but should be close enough. And then I'll add one of a darker color for the other side. Just like that. Then we'll go up to 40. This might be too big, actually. I think it's okay. Then we'll come back here and do the same thing. Yeah, that's okay. And then I'm going to just add an airbrush over that. That color could work, actually. Let's see what this looks like. Needs to be a bit bigger, a little bit less opaque. These are just some sort of artistic touches, if you will. I'm not going to spend too much time, though. We want to get to the development, the fun stuff. I'm going to duplicate this and crunch it up so it becomes the top part of the pipe. So I need the scaling method here, and I'll increase the width a little bit, and then I'll also I'll decrease the height. So I'll crunch it up there. This will be the top part of the pipe. And let's see what this looks like. That's probably too big. I need to crunch that up a bit more. That's better. Let's move that to where it's centered. I'll increase the width a bit more. And that looks okay, I think. Let's see. Yeah, I think that's fine. So I'll merge that down. And that'll be the last bit of art that we actually create for this tutorial. And this will be called pipe.png. Okay, a couple more things that we need. We need a button for play, a button for restart, and we need a bird. So let's go to flat icon and find those things. So I don't want to spend too long looking for anything. And we have to remember that we have to give attribution to the author of the art. So I'm going to go with a monocolor because I want to be able to change the color of the bird if I want to. This one looks okay. I kind of like that. Let's see if I think I saw something that looks sort of like the Twitter bird, like this one. This isn't exactly the Twitter icon, but I think this one looks good for what we want. So I'll add that up there. So we have our collection of what we can download right here. Now we need a play button. And if anything pops out, I think we can go with something like this, though. Yeah, let's just do that. And then restart. Or perhaps replay. Getting the right keyword is sometimes what you need to do. And this one looks perfect, actually, because if we look at this icon, it's sort of black, and then it has a white icon within it. And this is the same thing. It's black and it has the white icon within it. So we want that to be consistent, I think. Okay, so I think these are the only 3 ones I need. If I need more, I guess we can come back. I'm going to download this as a collection. That'll also give us the licensing attribution information that we need. I want to make sure that the color is white, because if the sprite icon is white, or the sprite color is white, then that means we can change the color to whatever we want within Unity. So now I'll download this as a PNG. I'll just say 512, make sure it's high quality. And we'll do a free download, of course. That'll download it as a zip, and that's going to go into my downloads folder, which is full of crap right now. But we will say okay. We'll find it in our folder. Then we'll cut and go to our project. So I'll paste this right here, and then I'll extract it right here, and I'll show you guys the licensing information within it. So we have license. We can make sure we read that. Let's see if I can open this with just Notepad is fine. I don't want to use any PDF reader. It'll take too long. And of course it's not going to read it. Okay, well, let's just open WPS. We want to be able to see what that's like inside. See what it tells us. Okay, but I can bring these PNGs in. I'll come back to that document. Let's go to Unity. Unity. Okay, and so my sprites have to re-import. Okay, now let me find, let's close this. So let's go to my folder so I can bring these sprites in. I'll rename these as well. So this is replay. This is play. And this is just bird. Okay, and then I'll just drag those into sprites. So let's look at that. Let's look at that PDF document, see what that tells us. So free license with attributions, we just have to give attribution to the author. And normally it tells us who the authors are, but it doesn't look like it's telling us this time. We're going to have to, we're going to have to go back to flat icon and figure that out, but we can do that a little bit later, I think. So there's nothing else in here. Okay, yeah, we can do that later. No problem. Let me go ahead and make sure all of this is good, all of these settings. We want to make sure we're generating mip maps. That's going to get rid of any anti-aliasing that we have. We'll add border mip maps as well. Actually, it's probably best that I show you what it looks like without. And you can see why I'm doing that. So this bird will bring down to size of about 0.25. Let's look at it from the game view. So we can see that there's a good bit of aliasing. And if you can't see that, you can zoom in here. Of course, the zoom in also adds aliasing. But let's just say from right here. Now let's go to our bird and add the mip maps functionality with the border mip maps, and we'll save this. We don't need a max size of 2048 because the image is only 512, so it has limited limitations there. Let's apply, and you can see the aliasing sort of blurs out, so it looks a lot smoother. And if I zoom out, you can't see any aliasing. So mip maps is really important. So I'm going to add that to, I'll just add it to everything actually. And I'll say 1024 because we had some bigger sprites in there as well. So we have all of our art, which is great. It's a great start. And we can consider our attributions later. No worries there. We have our game scene saved. We have fonts. And I think we are ready to start designing the UI. So let's go ahead and do that. Okay, for any UI, we need to add a canvas for starters. And we're actually going to use a screen space camera canvas. So we're going to drag our camera onto the canvas. That just means that wherever our camera is where our UI is going to be. That's actually just going to make it easier for us to design the UI placed right over the 2D sprites. This looks fine for now. We might modify some the sorting layer later, but for now we want to make sure that we're scaling with the screen size, and we can just say expand. That'll do a fairly good job of scaling. And after we have our canvas, we can start adding UI elements. So what I usually do with my pages is I put them in empty objects. So we need 3 types of pages for this game. We need a let's see, let me look at my list really quickly. So we're going to need a start menu, or I'll just say start page. We'll need a game over page, and we'll also need a countdown page. Now, these are all of the pages that'll be loaded dynamically, but we also have some static content, which is really just the score. So I think we should be able to see UI elements from here. Yeah, so showing up right there. So our score is going to our score is going to be placed up at the top. So let me set the width and height to be even. We'll say 60 by 60, and then I'll put a default value of 0 in there. We'll say best fit. Bring the max size up to somewhere around 100. Make it white, so it's nice and easy to see. So we can see it showing up a little bit better now. Let me bring the position.y up somewhere around there. And I'm going to change my font to FFF forward. Starting to look more like a game. That's a good font. And let's make it a little bit bigger. We can say 100 maybe, 100 by 100. Okay, that's a good size, I think. We can always change the color later if we need to. You know what I want to do is let's go ahead and bring our game objects into the game so we can see this UI being placed over our game objects. So see, our camera's right here. So let me show you that screen space element on the camera. So we can see our camera's right here and our canvas is right over there. Now, if I set my canvas to be screen space overlay, then I have to zoom out every time I want to look at the UI. So I have to come way out here. I don't want to do that. I want to be able to look at my game objects like this while I modify the UI. So let's start off by first changing our aspect ratio. Let's change our build settings first to Android. You can say switch platform. That's going to give us all of the aspect ratios that are supported by Android. So here we have our list, and I'm going to set this to landscape for starters. I know my UI element moved, but we'll come back to that in a second. So what I want to do is just add the game objects here. So we have a background. I'll set that to 0, 0. We have clouds. I'll set to 0, 0. And we have stars. Okay. 0, 0 as well. We also have a bird, of course. We can drag the bird in. And we can't see our bird. So why can't we see our bird? We can't see our bird because of the order in the layer. We're going to come back to that momentarily later in this tutorial. Let me change the size of my bird so he's to scale properly. That looks okay. Now remember I said that if our sprites are white, we can change the color of them. So as you can see, I can change the color of my sprite. That's because it's white. So that's going to be useful for us a little bit later. I guess I could set it to, I'll set it to black for now. And we can also change the size a little bit later. All I really wanted to do was take a look at the UI over the actual game colors. So now that we've done that, we can start messing around with the UI a little bit more. Let me go back to portrait, and now we need to find the text. There's no telling where that's going to be. Now, since the canvas is using this camera, the camera's depth matters. Although it shouldn't matter unless there's multiple cameras. So there's some reason why my canvas elements aren't showing up. Here we have a canvas, we have an order and layer. So on my actual canvas, I can change the order and layer. That needs to be above 0. We're going to create separate layers a little bit later. So we'll see how to do that. But for now, I'll just increase the number. Okay, let's bring this score up to where we want it to be. And then to make sure that this scales properly. Now, I want to make sure that it's centered. Take a look at what happens here. When I go to landscape, the text shoots off. Okay, so it's still there. It's just in the wrong spot. So this is where dynamic UI comes in. We have these things called anchors, and the anchors can keep our UI elements in place. Now, a trick that I use, pretty much works for everything, is I put the anchors on the outskirts of the rect. And no matter what I do with the screen resolution and aspect, it's pretty much going to stay where it needs to stay, no matter what. So that's a little bit of a trick. You just drag the anchors out to the outskirts of the or out to the corners of the rect, and it'll stay in place no matter what. Okay, so I'm going to design the UI in portrait mode since that's the default mode. Now, we have our score. Let me name this properly, score text. And then we need to create our start page. So what is our start page going to have? Our start page will have a button for play. So let's create a new button. And we'll set the size of this to, we can say 100 by 100 maybe. And let's use our play sprite. Then we're going to take a look at it from here. Now from the game view here, it looks like the aliasing is really bad, but when we actually publish this onto our phones, it's not going to look like that. I think the editor might be doing less work so it doesn't bog down the system. So it's not working too hard to make this look too good right now. So we don't need text, and this is going to be our play button. And our play button is going to have a job. We'll set up an event for that later, but not right now. So let's do our little trick where we, okay, so my start page you can see is just this little rect in the middle. So I can't actually move my children anchors outside of that. So what I forgot to do was I need to make the empty object rect the full screen size. The way I do that is I click on this anchor region right here and I hold Alt and Shift at the same time, and then I press this bottom right button. That's going to make the size, it does two things. It makes the size of my rect the exact size of the screen, and it brings my anchors to the outskirts of the screen. Now I can click on my play button and I can bring the anchors where they need to be on the play button. Perfect. I'm going to move the play button up a little bit. Okay, now we're going to run into another problem. If I change this to landscape, our play button stretches. So the reason it's doing that is because over here in my image component, I need to select preserve aspect. So that'll reduce any stretching whatsoever. So now if I go to landscape, it maintains the aspect. Now we can go back and look at the rect and see that the rect is stretched, but since we're maintaining aspect, the size of the button is going to be limited by the smallest width. So right now the smallest width is the height of the rect. If I bring the height up, then the button gets bigger. Okay, so that's what's going on there. All right, so something else that I want my start page to have is a text telling me my high score. So let's move this text component down. I'll color it white, set it to best fit. Best fit just means that the text will scale within the size of the rect. So let's sort of demonstrate that. If I scale the size of my rect, then my text will change size accordingly. And that's what best fit is actually doing. Okay, so I want this to, let me go back here and position that where I need it to be positioned. And Sego UI might be the best font for this. We can try, let's just try doing FFF forward for everything and see what that looks like. This is going to say high score, and then it'll tell us what our high score is. I can increase my width to make that bigger. And that's the best fit feature doing its work. Okay, so this is just going to be what my start screen has, a play button and high score text. So pretty simple. I need to make sure before I forget that I'm setting the anchors on my text. And this is just something that you need to do to make sure that your UI fits on every aspect ratio. It's a really easy trick. So with my game over page and my countdown page, I want to make sure I do that Alt-Shift trick. So Alt-Shift, bottom right button. Then I'll make sure that the size of my page is always going to be the size of the screen. Okay, so my game over page is going to have a restart button and my current score. So I'm actually going to duplicate these. So this text will be, that text is going to be my current score, like the score that I just died with. And this play button will actually be a replay button. Okay, so replay, we'll go ahead and I'm gonna hold shift and press this middle button. That's going to set my anchors back to the middle of the screen so that I can modify the X and the Y. I'll do the same thing with my text. So I'm holding shift and pressing the center button. So I'm gonna move my replay button up, and I'll just put that in the middle of the screen, and then I'll bring my current text to possibly right above, maybe. And this will say score. So this score is for the current session. This high score is for all sessions, whatever your highest score was. Okay, I want to make sure that these text sizes are fairly equal. So I'm going to reduce the height of this text so it looks like they're the same size. That looks pretty much right. Another thing that takes a lot of time with game development is just UI tweaking, just making sure everything is placed properly, everything is scaled properly. Those things can take more time than the development itself, than the programming. So I have the game over page and the start page done. Countdown page, and I'm going to go ahead and disable these for now. Countdown page is just going to be the 3, 2, 1 at the beginning of the game, and this is going to be placed in the center of the screen. I think it's a good place for it. So this will count down for us, and that'll be considered its own page. And I need to make sure that I'm setting my anchors. I'm not sure if I set my anchors. I think I already forgot on my game over page. Yeah, I set those. Okay, so we have all of our pages for our UI. Next, we're going to get into some more non-coding development. That's going to be dealing with things like rigid bodies and physics before we actually jump into the programming aspect. So we are going to get into actually writing the logic for these pages. But first, like I said, I want to get through all of the development that doesn't require programming. So we're going to do that next. I'm just going to create an empty game object, not right there. I'm going to create an empty game object to store my environment. So I'll call this environment, and I'm going to place my, do I have 2 birds in here? That's weird. So I'm going to add everything that's in the game into my environment. That's going to clean up my hierarchy a little bit. So I'm going to rename my bird. I don't know why I had 2 birds up there. Okay, my bird, I think, needs to be a little bit smaller. So let's make him 0.15, perhaps. I think that looks about right. Hopefully you guys will agree with me. Okay, and I want to add a rigid body. So let's just go ahead and play this, and we'll see that nothing is going to happen. And sometimes the first time playing just takes a while. Okay, so nothing's happening. We want our bird to continuously fall. And he's not actually going to be being propelled forward, but we're going to be dragging the pipes back towards him. So all that we need to do, all that we need to concern ourselves with as far as physics is concerned is having the bird fall. So there's a couple things we need. We need a rigid body. That's going to make our bird fall. That uses gravity. And I need to make sure I'm using 2D elements, so rigid body 2D. Don't worry about too many of these settings. Simulated means, you know, that's asking the question, do we want our object to be affected by physics or not? Simulated is yes, and not simulated is no. Don't worry about any of these settings. We don't need to concern ourselves with those, except for constraints. So I'm going to remove the constraint on the Z, or I'm going to add a constraint on the Z so that the bird doesn't rotate without us telling it. Other than that, we don't need to worry about anything. Now, if we run the game, then we'll see that the bird falls. Okay. So we're almost getting there. Now we need a collider 2D, and I'll add I think a circle collider is the most appropriate here. we can click on our object. Now, if we want to be really mean to the player, then we can leave the collider where it's at, and they'll get really mad because it'll look like they're not hitting the pipes. And that was essentially the behavior in Flappy Bird, I think, if I remember correctly. But we're not going to do that. We are going to bring the radius down to where it's somewhat manageable. Now, there's still going to be a bit of wing space or space between the wing and the head where they can get hit, and players might get upset with that. But we're just going to get as close as possible. And we could even say something like this. And with that, there's still quite a bit of room that is going to be left so where they won't get hit. So the bird could hit his beak on something without actually registering a hit. But I think we'll just stick with this. It doesn't need to be perfect. And we'll leave that the way it is. I think we want this to be trigger. So let's make that trigger. Trigger means that our game objects can just pass right through each other instead of actually bouncing off of each other. So we're actually going to simulate the actual stopping of the objects whenever they hit each other. And that'll be pretty easy. So we have our bird, we have our collider. Now we need to add our ground. So let's go down here and add our ground. There's our ground. Let's make sure that it's at the 0, 0 position. And our ground needs a collider too. So I'm going to put this in my environment, and I'm going to add a box collider to this. Now my box collider goes around the entire sprite, but that's not actually what I want. I just want the box collider, and I'll change the size from here. So I think the X is okay. I just need to change the Y. So the Y can be quite a bit smaller, and I'll change the Y offset. So if you pay attention to the green outline there, that's what I'm moving. That's the actual collider. And we can leave it there. So it looks like the bird will actually fall into the grass before it actually hits. I think that's all we need. They have some other cool settings here with Unity 5.6, but we actually don't need to modify any of that. I'll set the collider to trigger, and that'll be fine. Okay, so we have the ground, we have the bird. We need to add the pipes. Now, right now, nothing is going to happen. I can run, and you'll still see the bird pass right through, even though I'm using colliders. It's because we're using trigger colliders. And we'll get into more of that later when we start scripting. So now I need to add pipes. So let's add one of these pipes here. And this is just massive right now. It's obviously too big. Let's downscale this a little bit. So maybe 0.5 might be the right. I'm just going to downscale it until the width of the pipe looks good. The height doesn't matter because we can do some tricks to manage that. I'll just go down one more, and I think that is good. Now, of course, there is going to be a pipe on the bottom and a pipe on the top, and we'll make that part of the same prefab. But this pipe is still going to need a box collider on it. And that box collider will also be a trigger. So let's play with the width here. I want to make sure that's lining up just right with the edge and also the height. Okay, so that's hugging the pipe pretty good. I'm going to go with that. That's pretty good. We don't really care that it's not hugging right here because if the bird was right here, if the player was in this region, there's no way that they're going to be able to save themselves anyway, so they're going to die anyway. Right here, it's more important. We don't want them to accidentally go a little bit too low, but they're not actually hitting the pipe and they still lose. That'll just make them mad. So we're going to make sure it's hugging that region. Okay, so we have the bottom pipe, and I'll label this as bottom pipe. And then I'll duplicate it, and I'll rotate it on the Z by 180. And we'll call it the top pipe. And I'll just make the Y position inversely proportional. So instead of negative 3.59, I'll make it positive. And it looks like it needs to come up a bit more. So I'll say 5.3, and the bottom pipe will be negative 5.3. And this is where we're determining how big the gap is. So at this point, we're getting into a little bit of game design. That gap is too big, so let's change this to -5 and +5 to bring those in a little bit closer to each other. And that might be too close. That's probably too close. Let's do 5.15 and -5.15. And so again, this is defining the region through which the bird can pass. Now let's create an empty game object and set this to 0, 0. Okay, and then let's change the X position of our pipes to 0. Now this empty game object is going to be our pipe prefab. The reason I was setting those positions to 0 is because I want to make sure that my pipe parent is right in the middle of the bottom and the top pipe. So when I drag these in like this, okay, now this 0, 0 position is going to be controlling the pipe where this circle is. That is the actual center of my full pipe. That's pretty important. So now we need to define a region through which we can score, and that's going to require a collider as well. So I'm going to create an empty game object here, call it the score zone, and I'm going to add a box collider 2D to that. That's going to be trigger, and we can see our box showing up here, and that's fine. That would probably work, but we want to make sure that the bird is going all the way through, or at least halfway through. So we're going to make this a little bit skinnier. So I'll decrease the size on the X to something like that. And then I'll increase the size on the Y. So this will be the score zone. So if the bird's trigger collider hits anywhere within this score zone collider, then we'll register a score. Okay, now what we need to do is we want to add some tags. So object tagging gives us the ability to find objects quickly at runtime. And it also allows us to determine what types of objects we're running into. So I'm going to create 2 tags, and one is going to be dead zone and one is going to be score zone. So we have a dead zone tag, and then we have a score zone tag. Now the ground and the pipes are dead zones, so I'll tag those appropriately. And then our score zone is a score zone tag. So that's all the tagging that we need to do. Okay, and let's see what else we need to do before we actually get into the code. We need to create prefabs. So let me create a prefab for my clouds, stars, and pipes. Those are going to be our 3 parallax objects. Parallaxing is the process of moving objects a certain direction at different speeds to simulate depth. In other words, our pipes will be moving a certain speed. Those will be moving the fastest speed because they're the closest to our player and closest to our camera. The clouds will be moving a certain speed. Now those are going to go a bit slower because they're further away. And then finally our stars will be going at a certain speed, and those will be going even slower than the clouds because those are even further away. So that's the process of parallaxing. So when I say that we're creating parallax objects, that's what we're doing. Okay, and let me make sure all of this is centered. I don't know why. Oh, okay, I see. I'm going to make sure all of these are at 0, 0. And then I need to set my environment to 0, 0. Just making sure everything is 0 based. The reason that's important is because when we start spawning these parallax objects, they need to be, we're going to be setting the position based on the 0 being the center of the screen. So that's why that's important. Anyway, let's create our prefabs. The way we create prefabs is just take an existing object in the scene and drag it into our folder. So this is in our prefabs folder. So now we have the pipe prefab. We want the cloud prefab. So we'll drag that down, and then the stars prefab. Okay, let's talk about layering. Now, right now our layers are doing a pretty good job, but we want to make sure that our UI is always on the top. We want to make sure that our ground is always in front of the bottom pipe here. And we want to make sure that the rest of the game is on the correct layer. So let's go to our canvas, anything that has a sorting layer component on it, and we can add a sorting layer. Now, one sorting layer that I want to add is UI, and that's always going to be on top. Then I can also add a game layer. So let's start off with these two layers. We want to make sure that the UI is always being rendered on top. So this means that the score will always pass above the pipe as the pipes move across. So let me actually move that pipe over so we can simulate that. So you can see how the score is above the pipe right now, but I still haven't labeled our sorting layers. So let me set the bottom pipe and the top pipe to be on the sorting layer of game. So you can see now that the game is being rendered above the UI. Let's go back to, let's go to our canvas. Our canvas needs to be on the UI layer. Now let's go to our sorting layer. So UI, since it's on the bottom, it's a little bit backwards, but whatever layer is on the bottom is going to be rendered in the front or closest to the camera. So if I move the UI back, then the score disappears behind the pipe. So this is why sorting layers are important. We can say that no matter what, if our object is on a UI layer, it's going to be rendered above everything else. Okay, and this is sort of an top-down approach. So if we want to define more granular sorting strategies, we could say, for instance, the score text should always be above the start page. So we can set, we can create a new canvas like this, override sorting, and we can set its own layer right here. But we're not going to worry about doing that. The way we're doing this is actually making it a lot easier for us. Now we can see that the pipe, however, is, since it's on the same layer as the ground, I believe anyway, or no, actually it's not. So let's set the rest of our sprite objects to game. So ground, background, clouds, stars, and bird should all be part of game. Now, right now, the bottom pipe is where it should be. It should be behind the ground. And that could be based on where it's at in the hierarchy. But maybe not. So if I take this bottom pipe and I change the sorting layer to 1, since that's above 0, which is what the ground is at, then it's going to render on top. Now I want to make sure no matter what, because sometimes when they're the same value, they switch. So I want to make sure no matter what, the bottom pipe is always going to be behind. No matter what, it's always going to be behind the grass. Now we saw that it just went behind the background as well, so I can say that my background is always going to be behind everything. So we can set that to something like -10. Okay, so that should handle the bulk of our sorting. Now we could also say that no matter what, the clouds are going to be in front of the stars. The pipes are always going to be in front of the clouds. So let's handle that. And now we're getting to more granular order and layer stuff. So it's part of the same sorting layer. It's all part of game, but we want to make sure certain things are rendering above everything else no matter what. So I'll take my clouds, or let me take my pipe. Now my top pipe is going to be on a different layer. My top pipe always needs to be above the clouds. So I'll say 5. And I'll say that my bird always needs to be in front of the pipes. So I'll set my bird to 10. Okay, now if our top pipe is at 5, then we can say our clouds can be at 4 and our stars can be at 3. So stars are always behind clouds, clouds are always behind pipes, and pipes are always behind the player. Okay, so we've set it. I think we've set up everything that is considered codeless development. We've set up score zones and dead zones, triggers. We've added colliders and rigid bodies. We've added the layers and the prefabs. So I think we're finally ready to get into the actual coding development. So we're going to start off with the controller for the player. So let's go ahead and create our script to do that. So I'm going to create a tap controller for our player. So of course we need scripts. And then we're going to create a new C# script called tap controller. So let's open that up. Okay. Now this is going on the player, and I'm going to be doing some stuff with the rigid body. So one of the things I can do is secure one of my assumptions that the player needs a rigid body. So I can say require component type of rigid body 2D. So this tells Unity that if I drag a tap controller on my object, it's going to automatically create a rigid body 2D for me. So a couple things we need. Public float for tap force. We can set that to 10 initially. We'll probably be modifying some of these values. We need something for tilt smooth. So we're going to have the player actually rotate downwards as he falls. Then we're going to have a start position. So when we reset the game, where are we going to set the bird back to? So vector 3, start, pause. We need some private references, one to rigid body 2D. We'll call this rigid body. And then we need a quaternion. Quaternion is a fancy form of rotation. It has 4 values. It's a vector 4, essentially, x, y, z, w, all from values of 0 to 1. It's too complicated to go over, but it's a way of basically having secure rotation. So if you're ever doing anything with rotation, quaternions are the way to go. We're going to define a down rotation, which is what we are slowly going to be moving towards. And then we'll have a quaternion for forward rotation. So every time we tap, we'll snap right back up to that forward rotation. Okay, that's all we need for now. Of course, we'll be adding some stuff later. And start, we need to define some of these values. So rigid body is going to be equal to get component. Rigid body 2D, that gets the component off of our object. Down rotation is equal to quaternion dot Euler 0, 0, we'll say -90, and that should be putting him face down. So what's happening here is we're taking a vector 3 and converting that into a quaternion for us to use in our down rotation. So here you can consider x, y, z as normal Euler angles, normal vector 3 angles that we are used to understanding. Forward rotation can be equal to quaternion dot Euler 0, 0. And again, on the z-axis, we want to have him facing up a little bit. So we can set this to something, we'll say 35 for now, and see if that looks okay. Next, we want to say rigid body dot simulated equals false. This is going to say when we first start the game, we're not actually going to let him drop or be affected by physics. Although right now we don't actually need to do that, but we will be adding something like that later. Okay, next up, we can add an update function. So we'll say void update. We'll also have something for on trigger enter 2D. This is going to be looking for dead zones and score zones. This is going to take a collider 2D. Since we're in 2D space, we want to make sure we're using the 2D counterparts of these data types. So we'll be dealing with that a little bit later. So here we can just say if input dot get mouse button down 0. 0 indicates left click. 1 would indicate a right click. And this translates perfectly as a tap notification on mobile devices. So we don't need to do any pre-processor directives for detecting certain OSs. We can just leave it how it is and it'll magically work. So the first thing we want to do is say transform.rotation is equal to forward rotation. So remember I said every time we tap, we're going to snap back up to this forward rotation. Then we want to add a force. So every time we tap, we want to add an upwards force on our rigid body. So rigid body.add force we can say vector2.up times tap force. Tap force is that public member that we defined up top. This also takes a second parameter for force mode, so we can add force mode 2D dot force. This is actually the default force mode, but I'm adding it so you are aware of it. There's also an impulse that you guys can try out on your own time. So force mode 2D dot force. Okay, that's actually all we need for now. We also, or for tapping anyway, we also need to slowly move our rotation towards the down rotation no matter what. So we can say transform.rotation, and just so you know, transform.rotation is a quaternion. It's not actually a vector3 Euler angle. So we can say this is equal to quaternion.lerp. So if you've ever used lerp, it just means we're going from a source value to a target value over a certain amount of time. So the first value is our current value or source value, rotation. Second value is our target value, which would be down rotation. And then we have tilt smooth, which is a public parameter defined up top. That's how fast we're going to move towards that. And we want to define, or we want to multiply this by time.delta time. Okay, so I think we're good. Now we just want to check for whether or not we are actually hitting a score zone or a dead zone. So we'll add more stuff here as we continue development, but I'll go ahead and define what we need. We'll say if call, which is the collider2D dot game object dot tag. So this is how we access the tag, equals score zone. Then we'll do something. Here, if call dot game object dot tag equals dead zone. Remember, these are the two tags that we just defined. So here we will register. So here we'll register a score event, and we might play a sound if we get to that. So play a sound. In the dead zone, what we're going to do is say rigid body dot simulated is false. This is essentially going to freeze our rigid body, our bird. It's going to freeze him right wherever he hits. And then we can say we can register a dead event for scripts that we might need to know that type of information. We'll get into that a little bit later. And we can also play a sound again if we get to that. I think we're already about an hour in, and I want to try to do this in under 2 hours. Okay, so let's go ahead and go back to Unity and play this and see what it looks like. Okay, so back in Unity, and I'm going to find my bird, and I'm going to put a tap controller on him. And let's find out what his start position should be. So I think right there is actually perfect. Maybe put him a little bit higher to start off with. So maybe somewhere like this. I'm going to move that pipe back, although he's not going to do anything for now. So let's just say this, 1.22 and 0.81. I'll just copy and paste those values. The Z, I mean, the Z could be 0. The Z doesn't really matter because depth is processed by the order layer in 2D mode. Okay, so that'll be our start position, and we should be able to run this, and it should just work for us. Okay, so his tap force is a little low, but he did drop, and his rotation is moving properly. So we'll leave the tilt smooth where it's at. I think that's fine. Let's just bump this up to 200 or so. Okay. So I think there's something that we're missing here. Let's change this to 250. I see a bit of a problem. The way the physics works is when we add force, we're adding the force to whatever the current force is. Gravity is always affecting our bird. So if he's falling really quickly, our click isn't really going to do anything. So let's go back to our script and say every time we click, we're going to set the velocity to 0. Okay, so before we add any force, we want to sort of zero out our velocity. So let's say rigid body dot velocity is equal to vector 3.0. Let's go back and see if this improves the look. The look and feel of the game is really important, and we will spend a bit of time making sure that's right. Okay, that's much, much better. The only thing I would say is that his X tilt is a little too fast. It needs to be more gradual. Let me pause this and set his tilt to something like 1. That might be a little too slow, but it's looking better. So we'll try 2. All right, I think that's perfect. Okay, so our player controller or tap controller is done for now. The next thing we're going to get into is the game manager, which will handle menu item spawning and activation and deactivation of certain menus. And I guess we'll see what else is involved whenever we get into it. Okay, anyway, let's go ahead and create our game manager. So create a new C# script, call this game manager. Okay, and we'll go ahead and open that up. Okay, so inside our game manager script, we want to first create references to all of those pages. So the start page, the game over page, and the countdown page. So let's create a public game object for each of those, and as we need them, we'll activate and deactivate them. So we have start page, then we have public game object, not game manager, public game object, game over page, and then also a countdown page, if I remember correctly. Game object, countdown page. We also have a score text that we can keep track of within this script, so we can have public text, score text. Since I'm using that text data type, I need to add a using statement up here for unityengine.ui. So unityengine.ui, and I won't get any compiler errors after that. I want to know what my page state is, so I'm going to create an enum called page state. And let's see, always add a none to your custom enums. It's always useful to have in case you're not on any particular state. Then I'll add a start, game over, and countdown. Okay, so we have those page states, and we'll use a method for setting those. Then we'll have a score value, so that'll be an integer, initialize that to 0, and we'll have a bool to determine whether it's the game over state. So bool game over is false to start off, of course, and we'll make this accessible but not modifiable to other scripts. So I'll create a property for it. So public bool game over, that's just going to say get return the game over variable. So we can get this value, but we don't want any other scripts accessing it to modify it. Okay, we're going to, let's see, since on that note, if anybody needs to access the game manager, we should probably create a sort of singleton for it. Since we're not switching scenes, it doesn't necessarily need to be singleton, or we don't need to follow those guidelines, but we can say public static game manager instance. So we're creating a static accessibility reference from other scripts. So if they say game manager.instance, then they can access the public members within this class. So in awake, I want to define that. I'll just say instance is equal to this. Since we're not switching scenes, we don't need to worry about destroying on load or anything like that. If you're familiar with singletons, you know what I'm talking about, but otherwise don't worry about it. Okay, so my game is going to have certain events that other scripts are going to care about. So let's create a delegate. So delegate, public delegate void game delegate. And this is going to allow us to create certain events for other scripts to be notified of. So we'll say public static event game delegate. So that's our delegate name. And then we can create the name of our event, which is, we're going to have two. One is on game started, and we're going to have another one called on game over confirmed. We'll talk more about what those are going to be used for in just a little bit. So on game over confirmed, just like that. Okay, let's go ahead and come down. And we're going to have a method for set page state, of course. So let's say void set page state. That's going to take a parameter for page state. And in here, we're just going to switch whatever the state is. And based on the state, we'll deactivate and activate certain pages. So that should make sense once I start getting into it. So we'll switch on the state. We have 4 possible conditions. We have case page state dot none. We'll make sure that we add the break statement, and I'll copy and paste the other cases here. So we have 3 other ones, and that's going to be start. This isn't a semicolon, that's why these are being grayed out. These should be colons. Okay. So we have none, start, game over, and countdown. Those are going to be our states. And like I said, inside each one of these cases, we'll be deactivating the object. So we have start page. We could say if it's none, if there is no page state, then they should all be deactivated, right? So we can say start page.set active false. And we can say that for the other pages as well. So start page, game over page, and countdown page. Doing as much copying and pasting here to go as quickly as possible, of course. So this should start making sense. So for the start condition, we make sure that our start page is set to be active. So we say set active true. For our game over state, we say that the game over page is active. And for the countdown state, we say that the countdown page should be active. Okay, now we have, let's see what else we need. So we're going to have those buttons that we created earlier in our UI. We have a play button and we have a confirm game over button after the player dies. So we need public methods so that we can create some events hooked up to the game manager. So we need a public void confirm game over. So whenever the player dies, that button shows up with his current score, and it's the replay button. So when he hits that replay button, all of the logic, so activated when replay button is hit. And we'll talk about how to actually hook that up in just a second. Also for actually starting the game. So we'll have a public void start game. And this is going to be activated when play button is hit. Okay, I think for now that is going to work. Let's go back and hook these methods up to the buttons, and then we'll come back and see what else needs to be added to the game manager. Okay, so up in our canvas we have our start page, game over page, and countdown page. Start page has a play button, and let's open this up, and we have some events here. So on click, we're going to press the plus button to add an event. And let's add the game manager script that we just created. Let's add that to our main camera. And then, of course, let's, before we forget, drag the UI elements on here that we need to do. And I forgot to write the code for the score text, so we'll do that in just a second. So everything is hooked up for the game manager. Now, as far as hooking up that event, you can see it's asking for a game object here. I can drag the main camera in here, which has the game manager on it. So we can access, since this is the play button, we access that start game function that we just created. Okay, now the game over page has the replay button, so we'll do something similar. Only this time we are looking for the confirm game over method. So when those buttons are clicked, the corresponding code will run within our game manager. So let's open up our game manager and see what else needs to be added. Okay, so let's talk about what needs to be added in the confirm game over method. We're going to trigger that event on game over confirmed. That's going to tell our objects to reset, basically. So we're going to have our on game over confirmed. We're going to have our, this is an event. We're going to have our game objects reset whenever this event is triggered. Now remember that this is an event that we specified up here. Then we also want to set the score text equal to the 0 string. So we're setting our score back to 0. And then we also want to set our page state. So set page state to start game. So page state.start. So whenever we hit the replay button, the start game page will show back up, so we can hit the play button and start over again. So start game is just going to set page state for page state.countdown. So whenever we hit the play button, then we'll have the countdown page show up. So our countdown text is going to have an event as well. Let's go ahead and create our countdown text script. And we're going to be listening to an event from our game manager to say, okay, whenever the time actually runs out, whenever the countdown finishes, we can set the page state to none. We can say on game started, which is the event up here. And then we can set the score to the actual score, the int score, to 0. And then we can say that game over is equal to false again. Okay, we'll also be listening to events from the player, but we'll get to those in a second. So let's start off with creating the countdown text script. So right down here, we're going to create the C# script for countdown text. Countdown text. That's going to be placed on our countdown page, countdown text. So we can just go ahead and add that right now. Let's open that up. Okay, so we know that this class depends on the text component. So we can say require component type of text. With that, we need to make sure that we're using unityengine.ui. And we're going to have that text reference. So we'll have a text called countdown. And start, we'll go ahead, or we'll say on enable, because we'll be listening to an event from, or I'm sorry, we won't be listening to an event, but we're going to, basically on enable is going to get called every time we set this page to active. So we don't want to use start here. If we use on enable, then anytime the game manager sets countdown page to be active, then this on enable code is going to run. So we can say in here, countdown text or countdown.text is equal, no, just countdown, sorry. So countdown is the text variable. Countdown equals get component text. Then we could say countdown.text is equal to 3 because it's going to be initialized to 3. And then we can say start coroutine on countdown. So what is this coroutine? We have to create that. So that'll be an IEnumerator called countdown. So the way this works is we have the ability to wait a couple seconds or 1 second before we actually do something. So it's really convenient for something like a countdown. We can wait 1 second and then change this text to 2 and then change it to 1. So the way we're going to do this is start our count off at 3, and then we're going to say for int I equals 0, I is less than count, I plus plus. So this should loop 3 times. Then we say our countdown text is equal to count minus I dot toString. Then we yield return new. This is where we're actually telling it to wait for a second. We could pass any value we want here, but conveniently we only want to wait 1 second. So this will say 3, 2, 1, and then it should trigger an event. So we need to create an event that the game manager is going to listen to. So we can say public delegate void countdown finished. Public static event countdown finished on countdown finished. A lot of people will complain whenever I create my events as static. It does make it harder to manage events, especially if you're not comfortable with using events. You can run into a lot of issues that are hard to debug, but to me, I find it to be much easier to just make them static. You can make them public, but then you have to have a reference to the game object. And I've never really run into any issues with making them static, as long as I know what I'm doing. So I'll make my event static for this tutorial. And then here, we're going to say on countdown finished. This event is going to go to the game manager. So if we go back to the game manager, we can create an on enable. And this is just something I always do. I always subscribe and unsubscribe to methods in these two methods. So and on enable, I'm going to subscribe to countdown text. Countdown text, or countdown text dot on countdown finished plus equals on countdown finished. So I'm going to create a method within my game manager class called on countdown finished. To unsubscribe, you just say minus equals. To subscribe, you just say plus equals. So I need to create this method. And when I do that, remember, when the countdown finishes, I can just set the page state to page state.none. There's no longer a need to have any pages up until we die again. Also, I can say on game started, which is an event defined within my game manager that's going to provide some use to some other scripts that we'll see. And then I can set my score, my integer score, to 0, and I can say game over is equal to false. Now, how do we tell whenever the game is over? Well, we need to listen to an event that we're going to create within our tap controller. Remember, in our tap controller, we have the onTrigger enters, and here I want to register a score event. Here I want to register a dead event. Both of those events are going to be listened to by the game manager. So let's go ahead and define those events within our tap controller. We should definitely be getting worried right now because I've written a lot of code without doing any testing. So hopefully we run into minimum problems, but I mean, this is sort of a challenge for me. I want to see how fast I can do this. And yeah, I mean, so if we run into a lot of errors, I'm sorry, but we should be able to fix those pretty quickly anyway. So our first event, or our delegate, can just be called player delegate. So he's the delegate of these events. And then we can say public static events. I know somebody's going to complain at me for using static events everywhere. Somebody always does, but that's okay. And so I'll just use on player died, and then I'll use public static. You guys think I'm kidding, but I'm serious. People will get upset. They say it's bad practice, but here's the thing. I've never run into any issues with it. So I don't know. The only issues I've run into it is whenever I was a novice using events. But once you get used to using events and you can keep track of them, and you know, a good practice here, like as an example, what I'll do is I'll say that this event is going to be listened to by a certain script. So down here, whenever I actually score, I'll say on player scored, and I'll say event sent to game manager. So this is where using static events can be tricky, since you don't need a reference to, since my game manager doesn't need a reference to my player, it can be a little bit less than obvious that he subscribed to certain events. So if I want to sort of track where an event is coming from or where it's going to, then I can say that right here, make a note of it. So also I want to say that on player died right here, and we can also say event sent to game manager. Okay, so in our game manager, we want to make sure that we're subscribing to those. So we can have a similar format as to what we did here. I'll just copy and paste this. And the difference is this is coming from our tap controller, and this is coming, or this is our on player died or on player scored. So on player died, and then our second one from our tap controller is on player scored. On player scored. Okay, and then we want to make sure that we unsubscribe to those. Okay, of course we need to create the methods for those. So let's do that. We can just do it right below this one. So void on player died and on player scored. Okay, on player died, what we're going to do is say, well, first of all, game over is true. So we could say game over equals true. And then we could say int saved score. So we want to make sure that we're saving our highest score. we can say int saved score is equal to player prefs dot get int. There's a sort of like sub registry for each project that player prefs is saved in. We can call that whatever we want. That's going to be saved in some magical place, and what we're doing here is we're retrieving our saved score. So our latest high score is going to be saved in saved score. And then we say, okay, if our current score before we reset it to 0 is greater than our saved score, then we've made a new high score. And with that, we can say player prefs dot set int high score. These two string values need to be exactly the same so that we're modifying the same value. And the second parameter is the value that we're setting high score to be. So these two strings are the same. We're getting the high score here, and we're setting the high score here. Okay, finally we can say set page state to page state dot game over. So when the player dies, we open up the page that basically says game over. On player scored, we're just going to say score plus plus, and score text dot text is equal to score dot to string. That'll convert that to a format that our text component can handle. Okay, so like I said, I've written a lot of code. Hopefully nothing breaks. I'm sure I have a couple of errors that I need to fix. Make sure that I'm saving everything. But let's just go back to Unity and see what we're left with. Okay, so I have an error. The name onGameStated, I just misspelled that. Let's go back to the code and fix that. So it's started, not stated. And then we'll go back to Unity. Okay, only one error, very nice. So let's run this and just see what sort of happens, I guess. So if we hit the ground, it should be game over. Okay, and then our score pops up. We have a score of 0. We didn't pass through any pipes. Then I have the play button, so I can hit play. Now we have a null reference. So like I said, we're going to run into some issues. So game manager at 95 null reference exception. Let's see what that is. So something that's listening to my event, it looks like I didn't subscribe to it. Whatever this event is being sent to. So on game over confirmed, basically nothing is listening to that yet. That's the issue we're running into. So for now, let's do this and go back to Unity. Okay, and let's go ahead and play this and see if we can get past that error. Okay, so we're able to get past that error. Now we have the issue of our, and looks like we have another error at 49. We have an issue where the game isn't being reset whenever we hit play. Let's see what this error is. Okay, so also the same thing. My game manager is trying to send out events that aren't being listened for or aren't subscribed to. So the deal is, let me go ahead and make a note of this. So event is sent to tap controller here. And that's the same deal with onGameStarted. Okay, so onGameConfirmed and onGameStarted need to be listened for by tap controller. So what we'll do is we'll add the void onEnable and onDisable methods here. So I need to say game manager dot onGameStarted plus equals onGameStarted, and game manager dot onGameOverConfirmed plus equals onGameOverConfirmed. We'll talk about what each of these methods are going to be doing for us. It has to do with basically reconfiguring our game objects. Whenever we create our Parallaxer script, we'll also be subscribing to these methods, I believe, because we need to reset the pipes and reset all of the parallax objects. So let's go ahead and create these methods. Void onGameStarted and onGameOverConfirmed. Okay, onGameStarted, we need to reset the velocity to 0. I mean, think about if if our rigid body velocity isn't set back to 0 on game started, we have this sort of buildup of gravity. So when we press start, our player is going to fall really fast. So on game started, we want to make sure that our velocity is being zeroed out. Vector 3.0. The documents recommend that you don't modify velocity if you don't know what you're doing, or even if you do know what you're doing, you shouldn't modify velocity. But I've always found that having that control is better than not having that control. So rigid body dot simulated, we're going to set to true, because when we die, we want to set simulated to false, which is what we do here. So when we die, our bird stops listening to physics and it just freezes. That's what setting simulated to false does. Whenever we actually start the game back up, we want to make sure that we set simulated back to true. So what happens in on game over? We want to, on game over confirmed, so after we die and we say, okay, let's restart, we want to reset the position of everything. So here we want to say transform dot position or local position, because I think we're inside of a an environment parent object. So anytime you're inside of a parent object, you want to make sure that you're setting local position just to be safe. So local position will be equal to the start position, which is defined up top here. Okay, and then we want to set our rotation. Transform.rotation is going to be equal to quaternion.identity. At this point, remember, we haven't actually pressed play, so the bird will be set back to the start position, and he'll just be sort of freeze framed in a start position. So that's all we're doing here. Okay, so now we should be able to go back to Unity and see the ability to die and restart the game, and all that should be fluid. Okay, so after these scripts build, hopefully we have no errors, and let's play. Okay, we might modify that X tilt. Looks like it's still dropping a little bit too fast. But anyway, if we die, he freeze frames, so he's stopped there. We can press play. And it looks like our X tilt is still moving. And I think I know the reason why. But if we hit play, then it counts down, and then our bird starts falling again. But as you can see, he's still being updated when the game isn't, when we're in game over. So let's go back and say, hey, if game manager dot game over, we're not going to update anything. So in update, we can say if, let me get a reference to my game manager, and my game will be equal to game manager dot instance, and I can say down here if game dot game over, then return. We're not going to do any updating if our game over state is true. Okay, so let's run it, and that issue should be fixed. Okay, so he's stopped, he's not tilting or anything, and he won't start tilting until this countdown finishes. Perfect. So the only thing left to do is really to set up the Parallaxer and the score script. Let's do the score script first, because that's really easy to set up. So we're going to create a new C# script, or actually, I forgot the score is actually set up from the game manager, isn't it? Yeah, I already set that up. So we don't need to do anything else with that. We do have a high score text though. So if we look in our game over, we have this text. This is going to be our, actually that'll be in the start page, I think, because the game over page is going to be, let me see. Yeah, the game over page is going to be the current score. Start page should be the high score. So we need a high score text, and that's just going to be pulling the player prefs. So let's create that first. So high score text. High score text. Let's open that up, or let's drag it on our text first. After this, we'll do the parallax script, which is the last script that we need for this game, at least as far as I can tell. And after that, we will be pretty much done, with the exception to adding sounds and things like that. So I do want to require component of text and use Unity Engine UI. So we'll have a reference to high score text. In start, we'll say, I think we can do everything in start actually. High score is equal to get component text. And we're just setting the high score.text in the first, the first configuration. There's nothing dynamic about this text. So we can just say high score.text is equal to player prefs dot get int, and I believe that value is just high score like this. And that's all we need to do for high score text. And of course I have an error, so let's see what that's about. I need to set this as toString because it's returning an integer, and I guess it can't implicitly convert an integer into a string, so we just say .toString. Okay, and now we are cleared up, no errors, and the only script we have left is probably the most difficult one, because we're going to be getting into object pooling, which means that we aren't going to be calling instantiate or destroy at runtime only once in the configuration process. And then we're going to be moving the different parallax layers, so that would be the pipes, the clouds, the stars. We're going to be moving those layers at different speeds. So let's create the script to do that. It's going to be called Parallaxer. This is going to be a pretty big one, pretty important topic too. Parallaxer. And the Parallaxer is going to go on some empty game objects. Since we are doing this as a pooling technique, we're going to store all of the pooled objects within some parents. So I'll create an empty game object for clouds. I'll create an empty one for what else do we have? Stars, and then also the pipes. And the parallax script is going to go on all of these. So pipes, stars, stars, and then the clouds. And so those are our three parallax layers. Those are going to be moving at different speeds back towards the bird. The bird's not actually going to be moving forward, just up and down, but it will create the illusion that the bird is moving forward. So let's open up the Parallaxer script and see what we need to do. Okay, so I've sort of been dreading this. I know it's going to be a lot of work. Hopefully the script isn't too long, but the concept is sort of, I don't know, it's just a little confusing, I think. So we're going to create a pool object class. This needs to keep track of all of the objects of a certain type. So it'll keep track of all of the pipes, or all of the clouds, or all of the stars, and it'll be responsible for determining whether or not that object is in use. Because we aren't actually going to be instantiating during gameplay, except in start during configuration, because we won't be instantiating or destroying, we have to be determining whether or not that object is in use or not. So let's start off by just creating some variables for the pool object. We'll have a public transform. We'll have a public bool in use, so that'll determine if it's available or not. Let's create our, this is going to be sort of a condensed format. I don't necessarily recommend writing your code this way, but regardless, I'm going to do it anyway. So we'll have our constructor here that's going to take a transform to initialize, and we'll set transform equal to t. Down here, and I need a semicolon here. Now down here, I'm going to have two methods. One is void, public void use, or use. So if I call use, that means I'm setting in use to true. And then I'm going to have a method called dispose. If I dispose a pool object, I'm setting in use to false. So public void dispose, in use should be equal to false. Okay, so that'll be the extent of our pool object. Let's create some parameters. So we need to keep track of what type of prefab we're going to be spawning. So that's going to be a game object type of prefab. We need to know what size our pool is going to be. So how many objects should we spawn? How many pipes should we spawn? How many is going to be enough? We will figure that out with this parameter. So pool size, we'll have a shift speed. So how fast are the parallax objects moving? So shift speed. We'll have a public float for spawn rate. How often are these objects spawning? We'll also have to have some position information. So what's the default spawn position? So public vector3 default spawn position. How about whether or not we want to spawn immediately? So if you're familiar with the Shuriken particle system in Unity, they have a boolean called prewarm, and that basically means whenever you press start, the particles are already taking the shape that they need to take. So we're going to have a similar property called spawn immediate, and that's going to be responsible for setting up our parallax objects automatically at start. So we'll have a public bool called spawn immediate. That will be true for everything except for pipes, basically, because we want our clouds and our stars to already be in place. So then we also have the immediate spawn position, because that could be different from the default spawn position. So public vector3 immediate spawn position. I'll just say immediate spawn pause so that isn't too long. Then we'll have a target aspect. We'll talk more about that in a second. Target aspect is going to make sure that our pipes and our parallax objects aren't being spawned within the screen space. Remember, we have to consider, since we're publishing this, we have to consider all aspect ratios. The aspect is 4:3 on iPads, I think, so it's a lot wider than mobile devices in portrait mode. We might be setting a position that works in portrait mode on mobile devices, but doesn't work too well on something that's like a 4:3 aspect, because then we'll have objects spawning too close to the center and it'll look like they're popping in and popping out. So we want to make sure that our default spawn position and our immediate spawn position is made relative to our target aspect. Okay, now we also have a Y spawn range. Remember, the pipes are going to be spawned sort of randomly on the Y axis. So let's create a new struct here, system.serializable. This needs to be serializable so that the struct is viewable within the inspector. Public struct Y spawn range. This will have a public float for min and public float for max. So what's the minimum height of the spawn and what's the maximum height of the spawn? And up here, we'll place it above the default spawn. We'll have Y spawn range. Call that Y spawn range, just like that. Okay, a couple more member variables that we need to consider that are local. We need a spawn timer, so float spawn timer. We need to have an array of our pool objects. I'll put that down here. Pool object array, pool objects. We need to store our target aspect. So this, let's call these different names. The way that we are going to handle our aspect ratio is by dividing the width by the height. So if our target aspect is ratio is 10 by 16, so width by height, that would be portrait mode 10 by 16. We say 10 divided by 16 is our target aspect, because the camera class doesn't actually give us like an aspect.x or an aspect.y. It only gives us a x divided by y, or width divided by height. So we need to store our target aspect ratio within a float. That'll give us a close enough generalization of where we need to start spawning objects. Okay, then we'll have a reference to our game manager, because that's always nice to have. So let's create a skeleton. So we'll have awake for initialization. We're going to be subscribing to on game over confirmed. Remember, whenever we get on game over confirmed, we are going to be respawning our objects. So we need also start to initialize our game. The reason that this needs to be in start is because the game manager is defined within awake, and start is always called after awake. So by doing this, we're ensuring that game always has a non-null reference. We're going to be subscribing to events, like I said, so we'll have on enable and on disable. We'll have, of course, an update method for shifting, so update, and then some other methods down here. So we'll have a configuration method. That'll actually be called in awake. It'll also be called, here, let's go ahead and subscribe to the game manager really quickly. It's only one event, so game manager dot on game over confirmed plus equals on game over confirmed, and we'll unsubscribe and on disable, and we'll create that method right here, and make sure that we don't forget this unsubscribe minus sign. Okay, so on game over confirmed, that is just going to be handling disposing our pool objects and reconfiguring. So for now, we at least know that we can call configure here because we're going to reconfigure our game objects in this. But let's go through and add the rest of the methods that we're going to need. So we need something for spawning objects, our parallax object, so we can say void spawn. We need something for spawning immediate. Remember, there's going to be a different method for spawning if we choose the pre-warm option. I'll add a comment to that as well. So spawn immediate is like particle pre-warm. That's essentially what we're doing. So that's going to have a different spawn method. We need something for shifting. So how do we move the parallax objects? We need to check if an object needs to be disposed. So check dispose object, and we'll receive a pool object from that. So a pool object is going to be passed in here, and let me see what we have. We need to check if in use is true or not. Or actually, we're going to be, what we want to do for this is check to see if the parallax object is off screen. If it is, then we set dispose, which sets in use to false, which makes it available to be spawned again. So we also want a way of getting available pool objects. So transform.get, or just transform get pool object, that's going to return transform for us. And I think that's all of the methods that we need. So let's start off by, I guess this will sort of help us understand a little bit better. Let's determine how we're going to get an available object first. So what we do is get the first available object in our pool objects array. So we can say, let's just loop through it. Let's just say for int I is equal to 0, I is less than pool objects dot length, and then I plus plus. Okay, and here we say if not pool objects at I dot in use. So if it's not in use, if this object is not in use, we can just return pool objects at I. Okay. We also want to mark this as being used, so now it can't be selected again until it goes off screen. So we also want to say pool objects at I dot use. So we're calling use on that. That's going to set in use to true. We can return null. We have to return something in this method no matter what. So we will return null here. Okay, so that's kind of how we get pool objects. We can work our way up. How do we check if we need to dispose an object? So we can say, okay, if pool object dot transform, because remember our pool object class has a reference to the transform. If pool object dot transform dot position, not pool size, dot position dot x is less than, now what we're going to do here is start using the target aspect. So without the target aspect, we can just say default spawn position dot x. Actually, I'm going to do it that way, and I'll show you guys what I was talking about with the popping off and on screen. So conceptually, this should make a lot more sense though. So if the position.x is less than the default spawn position.x, now remember default spawn position.x should be off screen, should be spawning things off screen. So we can assume that the negative version of that should be off screen in the negative direction. So when it reaches that point, we can say pool object dot dispose, and that's going to say in use is now equal to false. Okay, we also need to set the position to someplace off screen, right? So we could say pool object dot transform dot position is, since it's not in use, shouldn't be considered in use. It should be off screen, so it's sort of hidden from the player. It doesn't need to be seen by him. So we can say that that's equal to some ridiculous value way off somewhere else. Okay, so that's checking dispose. So this is disposing objects and using objects. Okay, I think it makes sense to just keep working our way up. So how do we shift? Well, we can just continue looping through our object. So I is equal to 0, I is less than pool objects dot length I plus plus. Okay, and so we're just going to be moving based on, we should have a shift speed variable up here, so shift speed, and that's the speed that we're going to be using to actually shift our transforms. So we can say pool objects at I dot transform dot position plus equals negative vector 3 dot right, because we'll be moving to the left. All of our parallaxing will be moving to the left. So negative vector 3 dot right times shift speed times time dot delta time to make it frame independent. Now we also want to check to see if an object needs to be disposed. So this is where we're going to be calling this method. As we shift, we want to say, okay, is the position less than the dead zone, essentially, is what we're looking for. So is our pull object position less than the default spawn position? So we can say just check dispose object, pull objects at I, actually. Okay. Gonna jump around a little bit. So let's talk about configure. Let's see. So how are we going to configure? Well, we know we need to instantiate a certain number of these prefabs based on pool size. So when we start the game, we'll be instantiating things, and whenever, actually I just thought of something, we don't want to instantiate every time on game over is confirmed, but so we're gonna have to figure a way around that. So maybe we don't want to call this here. Anyway, just to show you what I'm talking about, in configure, we want to say that the let's go ahead and set the target aspect. So target aspect should be equal to target aspect ratio dot x divided by target aspect ratio dot y. Remember, the target aspect ratio is the variable that we have up here as a public member. We're going to be modifying that from the inspector. Should be 10 by 16 default Android portrait mode, I think, for most phones. Okay, so we'll set our target aspect. That's fine. So if for any reason the target aspect changes during gameplay, this should be reset every time we reconfigure. Okay, now we'll create the pool object array. Pool objects equals new pool object array, and that's going to be a size of pool size, public member that we defined up top. Now we can say for int I is equal to 0, I is less than pool objects dot length I plus plus. Then we can say game object geo, short for game object, is equal to instantiate. So we're actually going to be creating the object, spawning it into the game, but this should only happen once. And we're spawning the prefab, which is a public member we defined up top, and we're going to cast that as a game object. Make sure that that's the game object type. We want to store the transforms. Transform t is equal to geo.transform. We want to set the parent to this current object. Remember, we put the Parallaxer script on all of our parent objects. So t should actually set the parent. This new instantiated object, t, should have the parent of whatever object this script is attached to. So we can just say t.setParent transform. Now what we want to do is set the position. This is basically initializing it off screen. So t.position is equal to vector3.1 times 1000. That's off screen for sure. Now we can actually initialize the value within our pool objects array. So pool objects at I should be equal to a new pool object where the value passed as a parameter is just t. That's the only parameter within the constructor pool object that we need. Okay, now we want to say if in our configure, if spawn immediate, so if that spawn immediate boolean is true, then we want to call spawn immediate. Okay, now spawning isn't necessarily the same as what we did here. For our parallaxer, we consider spawning as placing them in the correct position, the objects in the correct position to be shown on screen. So that's what we're going to define as spawning. So if spawn immediate, then we want to make sure that we're calling that version of spawn. Let's go through the regular version of spawn right here. So every time we spawn something, we want to say transform t is equal to get pool object. So we want to get the first available pool object. If t is equal to null, so we actually couldn't find an available pool object, we're just going to return. We can't do anything. If this is true, so if true, this indicates that pool size is too small. All right, hopefully that makes sense. Now we're going to define the position that we want our parallax object to be placed at when we spawn. So vector3 pos equals vector3.0. I'm just going to initialize this to vector3.0. And we're going to set the x and the y. Now pos.x is going to be equal, and again, I'll just say default pos, spawn pos.x. This needs to be dependent upon the target aspect, but I'll show you what goes wrong and why we need to consider the target aspect. And then we'll come back and modify this code accordingly. Pos.y is going to be equal to random.range, y spawn range. Nope, that's actually the type variable. So that needs to be lowercase y spawn range dot min and y spawn range dot max. So a value between the minimum and maximum specified from the inspector. Finally, since pos is an independent variable, we want to set that transform.position equal to pos. Now remember, transform, this t is coming from one of our pool objects. So all we have to do is set the position and we can consider it spawned. Now what's the difference between this and spawn immediate? Well, remember that spawn immediate cares about sort of customizing or pre-warming the position where something is spawned initially. So let's go, oops, I just knocked my mic. So let's go to Unity and see if we can figure out what I'm talking about. Okay, so I know I have this error, but I'll address that in a second. So let's consider our clouds. Our clouds are going to be one of the parallax objects that we want to be pre-warmed or spawn immediate. So the thing is, if we don't spawn immediate, then what we'll end up with is our clouds moving over. And then once they get off screen, then we'll get something spawning over here. We'll get some new clouds that spawn over here off screen. And there's going to be this big gap of clouds. We don't want that. What we actually want is for our clouds to be spawning off screen right there. But we also want our clouds to be initialized at 0. So we're going to have 2 cloud objects initially. So initially we should have 2 cloud objects spawned, and then as these move over, what's going to happen is when these clouds get into a certain position over here, that's when the new clouds will spawn on the right side. We'll actually see this in action. It's a little bit hard for me to explain, but I'll try to show you what it looks like when it's bugging out, and then I'll show you what it looks like when it's working properly. But essentially what I'm trying to say is that our spawn immediate function needs to spawn 2 versions of this, one right in the center of the screen and one on its default off-screen position. And that's going to be our sort of pre-warm for our parallax. Okay, so let's go back to the script and let's look at this error first. Parallaxer already contains a definition for y spawn range. let's open this up, see what it's talking about. Yeah, so this needs to be a lowercase y. That's my bad. And that should fix that error. Okay, let's go back down to spawn immediate. So this is going to be really similar. We're just going to copy and paste this, and then we're going to call spawn under this. Because remember, one of those objects, the clouds on the right, if you can imagine, are the objects that are being spawned from the default spawn pause. Now remember, spawn immediate is going to spawn 2 objects. Only this object should be placed at the immediate spawn pause.x. Okay, and that should be it for our spawn immediate. Okay, now we can look at update and see what we need to do there. Just like we did in the tap controller, we don't need to be updating if game.gameOver, so we can return if that's true. And then we want to call shift, so we're going to be shifting these parallax objects. Then we want to increase the spawn timer plus equal time.delta time. If spawn timer is greater than our spawn rate, I think is the name of that variable, spawn rate. Yeah. So if spawn timer is greater than spawn rate, then we could say spawn timer is equal to 0, and then we can call spawn. So that makes sense, right? And that's all we need to do for update. Now, on game over confirmed, we want to dispose all of our objects. We want to basically, remember, dispose should move them off screen like this. So we want to call dispose and move them off screen. So that's what we're going to do on game over confirmed. Remember, the bird will go back to a start position on game over confirmed, and so we should restart all of the game objects on game over confirmed. So let's go ahead, and I believe that might be why I called configure. However, we only want to do this part. Let's do this. The only part I really care about with configuring or reconfiguring is checking the spawn immediate value, because we don't need to recreate the pool again. So this should work, but if it doesn't, we can always come back and fix it. Let's go ahead and say if spawn immediate, then spawn immediate right there, but we also want to dispose all of our objects. So for int I is equal to 0, I is less than pool objects dot length I plus plus. Then we say pool objects at I dot dispose and pool objects at I dot transform dot position is equal to vector3.1. I told you guys this was going to be a big script. I did warn you. Way off screen, so times 1,000. But we are almost done, and we almost have a functioning game, and we must be up around 2 hours at this point. But hopefully we have enough time to add sounds. So I think we can start testing. I want to make sure there's nothing else. I guess we can just play it and see if we have any issues. Okay, so we do have an error, Parallaxing 21. It looks like a misspell. So this should be object. And we'll go back. Okay, cannot implicitly convert type pool object to transform. So let's see what that's about. So here, since our return type is transform, we want to make sure that we are returning the transform property within our pool object. Okay, no errors, looks good. Now I need to just set up some variables for let's just do the pipes to start off with. The clouds and the stars aren't really important. Pipes are the real gameplay. So let's set up the variables in the Parallaxer. So we'll add the pipe prefab. The pool size, we'll say we probably shouldn't need any more than 5, but we'll see. I'll set 10 just to be safe. Our shift speed, I don't really know yet. So we'll say 1. And spawn rate, again, I don't really know. I'll just say every 2 seconds. Spawn range. Now here what we can do is look at our pipe. Let's set, okay, so the Y is already at 0. So what I'm looking at, if I go back to pipes, I'm trying to figure out a min and a max for the Y spawn. So what's the smallest Y value and what's the biggest Y value? So I'm going to click on my pipe here, which is centered at 0 on the Y. And I'll say, I'm just going to look to see what I think the best value looks like. So On the Y, I would say that looks good, 2.72, and the min could be 1.79, negative 1.79. So 2.72, negative 1.79, 2.72. Okay, so we're gonna, of course, play test this and see if it works. We don't need spawn immediate on the pipes default spawn position, so now I can determine what the best spawn position might be. So I'll set my Y back to 0. So on the X, I'll just move it until it's off screen sufficiently. I'll say 4.5 is a good value for the default spawn position. So 4.5, and our aspect, target aspect, should be 10 by 16. Of course, that can be whatever you guys want. Okay, I think that's gonna work. I'm a little bit nervous, but let's just see what happens, I suppose. So I'm going to deactivate this pipe, and let's just run it. So no errors, that's a good sign. My bird is tilting a little too fast, so it doesn't look like, and then my game froze, so that was weird. I think my pipes are on the wrong layer. Let's run that again and pause it, see what's going on. So I definitely have pipes spawning. My suspicion is that those are on the wrong layer. Yeah, you should be on the game layer. So they are spawning, but if you take a look, I'll change the sorting layer to game, and now that one's showing up. So for some reason, or maybe I just didn't apply this prefab. So let's run this again. So I just applied the values after I'd been changing it this whole time. There we go. Now that is way off. Something's definitely going wrong there. Let's just run it again. I want to look at that transform. So we have some pipes spawning. The scale is way off. The X and Y is way off. I don't know what's going on there. And I do have a suspicion, though. I'm going to say that. So let's go back to our script. My suspicion is we need to be modifying the local position. Remember I said if you're working within a parent game object, it's always best to go with local position. And that's what you should be shifting on, is the local position. I don't know if that's going to work exactly or not, but we can definitely try it. Okay, so we're coming back and trying that out. So let me pause. Now so that definitely wasn't the answer. For some reason, my pipes are a canvas. Oh no, that's okay. Yeah, so some of you might have caught this, but I need to copy that component. Yeah, my pipe shouldn't be UI elements. I was wondering why the positions were so far off. These need to be within the environment. Let me create empty game objects within the environment. I was getting really worried there because that definitely didn't look right. And then I'll paste the component as new, so all my values are maintained there. Okay, let's run it again. I think this is going to fix it. I want to change the bird's tilt speed. I think it's a little too fast. And it looks like that got reset too. I think I set that to 2. Okay, let's run this again. And it shouldn't be, okay, let me go back to my tap controller. So it shouldn't, the bird shouldn't be moving until I hit play. So I need to set rigid body and start rigid body dot simulated to true, or false, I'm sorry. Okay, so now when I play, the bird shouldn't be falling, but he is tilting. That must be due to game over. I should initialize game over to true, I suppose, because when I press that play button, it sets it to false. Let's see. Start game. I say game over is false on countdown finish. Okay. So let me initialize game over to true and then go back. Okay, so just a couple little things that need to be fixed. We knew that we would run into things like that, but that's okay. Okay, good. So it's not going to start until I hit play. Now there's another issue that I want to fix really quickly, and that is my UI. This needs to say high score colon and then the high score. So let's go back to our high score text script. In our high score text script, we need to concatenate this value like this. So we can say high score colon, just like that. And I think I did a similar thing in my game manager. I just set it equal to, yeah. So score.text should be equal to score, or no, not this one, but the text that I'm using in my game over screen. Okay, let's just play it and see what's going on. Okay, I don't want to get sucked into all of the little bugs. Let's just see if we can play it. Okay, so there's the countdown. And we can play. And there's our pipes, correctly sized. But they are definitely too close together. My scores are going up. Doesn't look like my score is being set here. So we can fix that though. That's not too big of a deal. Let's go ahead and address that. My score text is in my game over page, and I don't actually have anything for that. I definitely need to have a script for that, I think, or let's see. I think I can just put my score text component on that. Let's just create a new script for it, and we'll just call it score text. Yeah, that's going to be the easiest thing to do right now. So I'll edit this. This is using unityengine.ui. We have a text component, and in start is the only place we need to set that. So score is equal to get component text score.text equals score like this plus we can say game manager dot instance dot score. We should be able to. Let me look at my game manager. I feel like there should be something built in here for my score, but I don't think there is. So what I'm going to do is create a public property for this and just return score. And then I can say within my score text, game manager.instance.score. So this should work. Let's go back to the game. And now I just want to see when I die if I get the correct score. Now my high score is working, so we can see high score is equal to 2, which is true. I just want to make sure that that game over screen score is showing up properly. So I'll get 1 point and then I'll die. Okay, so now we see score 1. I suppose this isn't really necessary since we have the score up here. So I'm actually going to get rid of it. I'm just going to say that that says game over. Another thing that I just noticed is that this button needs to be the replay sprite. So let's fix those things. So like I said, I'm not going to use the score text. That was sort of silly on my part. All this needs to say is game over. And I need to set my replay button sprite to the replay sprite. Just like that. So I'll go ahead and delete this. And now we need to work on our pipes. So we want to make sure that those pipes are being parallaxed properly. It looks like everything is working, but the spacing was off. So here we're getting into sort of the design aspect of the game. So what I want to do is take my bird and just turn off his collider so I can never lose the game. That's my reason for doing that. And I'm going to press play, and I just want to take a look at this from the side. So I should see my pipes coming in. They're coming in at the right position. What I need to do is go in and click on my pipes here and change the shift speed. Looks like it could be increased a little bit. So I'll increase the shift speed to 1.25 maybe. Okay, so then I'll also increase the spawn rate to 3. And we can see that this is changing pretty much right off the bat. So this looks pretty good. They are deleting and spawning perfectly off and on screen. Now I'm going to show you why we need to care about this aspect ratio, because remember, we didn't actually implement that yet. I'm going to save this component, copy component, and I'm going to make sure I paste those values that I liked. Now let's go into landscape mode, or let's just go into something less dramatic. Let's go into a portrait that is closer to an iPad, so maybe 3:2. We can do 3:2 portrait. We might be able to see it popping from here. Let's see. Okay, so it's not popping from here. I guess there should be one of these. Let's try something that's a little bit wider. So just to show what I was talking about, I don't even have a 4:3 aspect on here. Let me just add that aspect ratio. So we can say the width. I think that's the aspect of an iPad, but somebody can correct me if I'm wrong. Okay, so we're on the 4:3 aspect. Let's run this again. And we should see popping, or else I suppose I'm a liar. Okay, so it's popping on the screen space right there. So if somebody was playing this on an iPad, it would just look really buggy. And it'll pop off the screen space right there. So this is where target aspect ratio is important. You'll see what this is going to do for us. We can use a ratio to increase the spawn positions based on the width of the screen space. So let's go back to our Parallaxer script. And in our Parallaxer script, what we want to do is we can start off by the check dispose object. So this is whenever it's checking if it's off screen. So we can say negative default spawn position, and we can multiply this by our current aspect. So camera.main.aspect. And we divide this value. We divide this value by our target aspect, like this. And that's what we want to do whenever we spawn as well. So if we're looking at our spawn method right here, this needs to be default spawnPos.x times camera.main.aspect. What's the current aspect of the camera is what we care about. And we're going to use that to increase or decrease our spawn position divided by target aspect. Think about if our target aspect is what the actual screen space is, then by simple math properties, camera.main.aspect and target aspect turn into a value of 1. 1 multiplied by default spawn position.x is going to be just default spawn pos. So if our current aspect is the target aspect, then nothing changes. So that's how you can think about this ratio. All right, we need to do the same thing with spawn immediate. So we want to make sure that we're multiplying this by, camera.main.aspect and divided by target aspect. Now, when we run this without changing any aspect properties, when we run this on the 4:3 aspect, we should see that they're spawning and being disposed properly. Okay, so let's just run it and see if it works. It should work automatically. Okay, so here come in the pipes. It's not going to be completely perfect. they might be spawning a little bit too far off, but they're off screen nonetheless. So it's certainly better than having them pop on screen and pop off screen. Okay, so that's fixed, and we can go back to our normal portrait mode for the rest of our testing. So I think I have the pipes spawning properly, doing what I want them to do. Now I'm going to get rid of these clouds and stars, and I'll get rid of this for now, I suppose. And I'm just going to duplicate this for the clouds and the stars. So my clouds parallax layer and my stars parallax layer. So my clouds, they're going to be using the clouds prefab. I can decrease this certainly to probably 3, but I guess to be safe, I'll say 4. So that's the maximum number of objects that will be instantiated at runtime. Shift speed, this will be much slower, so we can say probably 0.25, and the spawn rate, we can say something like 30 or maybe 40 seconds. Our ymin and max, I'll just say maybe that's a variation of 1. So the maximum range on the y spawn is just a value of 1, so that's pretty small. The default spawn position will probably be somewhere around 15. Let me just drag my clouds back into the scene to check that. And I shouldn't have deleted those. So my clouds need to be on game. Let's see if I can. No, I don't want to do that. I did change my layers earlier in the tutorial. I think my clouds were, let's see, what is the layer that the bird is on? Okay. So what about the pipes? Let's see, the pipe layer is 5. So my clouds need to be behind that. So I can say 4. My stars can be on the 3rd layer. So let me bring those back on. Yeah, they weren't showing up, so I had to make sure I changed that. Okay, and I'll go ahead and save these prefabs. Okay, so I'm looking for the cloud spawn position. So I'll duplicate this, and the cloud should be spawning over here. Right there would be good. That's basically our cloud trail. So I'll do a similar thing with the stars. Well, the stars should be in the same exact position. 17.44 is the number. So I'm going to go to our clouds parallaxer, and I'll set that to 17.44. These will be spawning immediately, and the spawn position X will be 0. Okay, so I'll actually copy this since that's most similar to stars. And the only thing we're going to change is the stars prefab for our stars parallaxer. We'll change the shift speed because these should be shifting slower. So we'll say 0.1, and then we'll say the spawn rate is like 75. I don't know if these values are going to work, but they should be good enough, at least for now. Yeah, so I'm going to now delete these. And when I run, we should see everything showing up. Okay, so everything is showing up. It looked like they were moving the wrong direction. Oh, nothing is actually moving yet because we're not playing. So this is the pre-warm I was talking about. We have 2 clouds, or we have 4 clouds. What's going on there? Okay, so there's a little bit of a bug, I think. Oh, no, that's not a bug. Our pool size is 4. So we spawned 4 clouds. We have 2 that are up here, these top 2. So those are the top 2 that are actually positioned. So that's our pre-warm. Same thing with the stars. We have the top 2. Those are being there. Pre-warmed right there. So that's exactly what we wanted. So let's take our bird, turn off his collider, and see if we can get these moving at the correct rate. So I'll press play, and then everything is moving. That's good. To test this a little easier, since they're moving so slow, I'm going to write some code that increases the time scale, so it'll make everything move faster. So let's go ahead and do that. Everything looks like it's working right now, though, so that's good. Okay, so I'll say from my tap controller, what I'm going to do is say if input dot Yeah, I know I already have one here, but yeah, I'm just going to say, okay, if I click, then I'll increase the timescale. Time.timescale. This is sort of a debug property, I suppose. I'm just going to get rid of this. Plus equals 1. You'll see what this does. Let me go ahead and run it. So what I'm trying to do is just make sure that my clouds and my stars parallaxer is lining up properly. So I'll go ahead and run this. I'll set my bird collider off so he doesn't die. And then I'll press the play button. So that's going to run. Now if I click in the game, it'll increase the time scale. And again, I'm doing that so I can look at the clouds and see whenever they're popping out and popping in. So it looks like the clouds are popping in a little bit too soon. So I'm going to increase the spawn rate to, let's say, 60 and see what that does. I'm going to increase the time scale a little bit more. So it should spawn. Okay, we're almost there. Let's say 65. Probably 70. Okay, I need to let these run through. When I change it at runtime, it thinks that the spawn time is 7, so it spawns a lot faster. So once this runs through, we can check it for sure. So after these clouds get to where they need to be and they spawn, I can confirm that it's working. Okay, that looks perfect. So they're definitely spawning almost perfectly. Now I just need to check the stars. So the star shift speed actually doesn't look that bad. It's going to be harder to tell if the stars are off or not. In fact, I don't even mind if stars are overlapping a little bit, but I do know that the cloud shift speed is almost 3 times as fast. Spawn rate is 70. So this spawn rate should definitely be increased. I'll just say 150. And that should make sense for me, I think. Okay, so I'm going to copy this to make sure I have those values. And just remember the value that I had for the stars. So post component values. And then this one was 150. Okay, so everything is working in terms of the parallaxing, which is great news. Let's just play it and see if we find any issues. So this is, I suppose, the fun part. And it looks like we're... Uh-oh. So I wasn't paying attention. Let's see what happened there. My gravity is accelerating really fast. Oh, I forgot. Let me go back to my code. I forgot to, every time I'm clicking, I'm increasing the time scale. So that would be a really difficult game. Now we can go back and it should be fixed. Okay, so about to play the game. Just going to see if there's any bugs. And if there's not, we can set it up for publishing. I have a feeling I'm going to get a little bit addicted to this. You know what I want to do is add some red on the background of the game over. And I know I'm going to be tweaking this. I also want to reduce the tap force. It's a little too strong. I'll say 225. Now, what was I going to do? Okay, on game over, what I want to do is add a background image. So I'll place that above the text, so it's drawing behind everything. And I want this to be sort of a red tint. So something like that would be perfect. Okay. I'll turn that off. I'll turn the start page off. Okay, let's run this. Oh, I actually need the start page to be on initially. Okay, let's see if we can get a high score greater than 2. Should be able to, right? Okay, that tap force feels a lot better. With a game like this, you know, simple as it may be, the feel is really important. And tap force is also really important because we don't want our bird to be able to tap within the pipe, at least when he's at the lowest position of the pipe. So this might be a little bit too easy. It's definitely too easy. Either the pipe width needs to go down, or I need to increase the tap, or I need to increase the tap force. So I would rather decrease the pipe width. So what I'm going to do is change this to say 5.05. No, we'll just say -5. And then the top would be 5. So that moves it in, it inches it closer just a little bit. Another thing I want to do is increase the speed of the pipes. So let's do that. Let's increase the speed just a little bit. We can say, instead of 1.25, let's just say 1.5 and see what that looks like. Because I don't want this game to be too easy. It's Flappy Bird after all. Okay, that's much better. It's definitely going to be trickier. The only problem now, obviously, is that they are too far apart. But as far as the tap force and the height of the pipes go, it's definitely going to be a lot harder. So this is easy now because the pipes width are so far apart. So let me go ahead and change that. And the way you change that is just by decreasing the spawn rate. So we'll say 2.25. So spawns a little quicker, moves a little faster. Should definitely make it harder. Our clouds and our stars are parallaxing really nicely. I like that. Okay, this is pretty much perfect, I think. This will definitely be tricky, I think. So I'm just going to play this for a little bit. I'll probably do a time lapse, and if I run into any bugs, I'll just stop the time lapse and address those. Actually, I just saw a bug. Looks like the stars are drawing above the pipes. So let me fix that. The pipe, yeah, the order and layer should not be, okay, no, never mind. Okay, the pipe is at order and layer 5, and the stars are at 3. So why were the stars drawing above? Okay, I just have to run that again and see it happening and then pause the game. So you'll see this star right here drawing above the pipe. I need some sort of God mode. Actually, I don't need God mode. I'm just going to move one of these pipes. So that's kind of weird. I definitely saw a star drawing above. Maybe some of you did too. There it is. It's the bottom pipe. So that's definitely an issue. Our stars are probably just spawning too low. I need this bottom pipe. Well, I could set the bottom. Okay, I think I know what I have to do. So the bottom pipe needs to spawn above this star, or it needs to draw above this star, but it needs to draw behind the ground. So let's just do a little bit of layer tweaking and fix that. The bottom pipe, I'm just going to put it the same as the top pipe, so 5, but then the ground is drawing behind the pipe. So we want to make sure that the ground now is at, we can just say 6. So that's probably a better way of doing this. So bottom pipe needs to be 5 and the ground needs to be 6. Okay, now I'll probably do a time lapse, and if I run into some bugs, then I'll stop it and we can address those together. Okay, so it's definitely really difficult. I don't think I'm going to change that though. I think this game needs to be difficult. That's why it got so popular, I think. But the thing is, my top wing always clips. So the tap force and the width of the pipes is what's going to make this game challenging or easy. And right now, those are just like perfectly aligned. So it's just a really difficult setup. I can make it easier. Maybe I will before I publish it. But I'm going to take a little bit of a break, and then we'll come back, and well, it's going to seem like a second because I'm just going to skip the video. But I'm going to take a break, just so you guys know, and we'll come back and talk about publishing. Hey, this is a really long video, isn't it? But we are making a full game and publishing it. If you like the format, then let us know by smashing that like button, and then you can leave a request for the next mobile game that we should clone. Is there something that we can improve on? You can tell us that in the comments as well. All right, guys. It looks like this is going to be about a 3-hour video. We have about 30 minutes left, I think. So that gives us enough time to add sounds. I know we said that we're going to get into publishing, but I did forget about sounds. So there's this application called Bfxr. You can Google it and download it. So I think it just works based off of sort of randomized noise, and then you work with these sliders to get it to sound the way you want it to. So we need a sound for tapping, scoring, and dying. So I'm going to work on getting the sound for tapping, and then I'll let you guys listen to it after I mix around a little bit, and we'll work like that until we have all the sounds, and then we'll go back in Unity and actually go through the code for playing those sounds at the appropriate time. Okay, so I think I'm going to go with this sound for the tapping. So it's not exactly like a flap, but I think it sort of fits. I mean, it's sort of silly, I suppose. So I'm going to export this as a wave, and I'm going to find my directory for my game. And let's see, sounds, and this will be tap.wave. So we'll save that. Okay, and the next one I want to find is the die sound, so I'll work on that, and then I'll let you guys listen to it. Okay, so I think I'm going to go with this for if the player dies. It's just something quick and sort of deep, so I think that'll sound okay. Now the next one I want to do is for scoring, so that one should be a little bit easier, but I'm going to make sure I don't forget to export this, and this is going to be called die sound, so die.wave. Okay, and like I said, I'm going to work on the scoring one, and then I'll let you guys listen to it, and then I'll save it, and we can go back to Unity. Okay, so this is the sound that I'm going with for scoring. And I'm going to export that, and then we can go back to Unity and see how to implement these things. Okay, so I can close this, and let's go back to Unity. Okay, so our sounds show up as waves, which is exactly what we needed. Now, I think all of this can actually be implemented right inside the tap controller. So let's go to the tap controller and see what needs to be done. Okay, so we want to add 3 audio sources. So public audio source, tap audio, audio source, we'll have score audio, and we'll also have die audio. Okay, and all we need to do is, let's see, so when we score, we can just say score audio.play. For our dead zone, we can just say die audio.play. And then our tap audio is going to happen inside this get mouse button at 0. So we can say here tap audio.play, and it's as easy as that. So the only other thing we need to do is actually add the listening components to our player. So let's go ahead and do that in Unity. Okay, so our player is our bird, and I'm just going to add some empty game objects for tap, die, and score. And I'll add some audio source components to these. So audio source, play on awake is false. The audio clip for tap is tap. We can play with the volume after we actually play it. We can see how it sounds. So I'll just copy this component and paste it on these 2 objects. The only thing that needs to change is the actual audio clip. And after we do that, we can just play and see how it sounds. Okay, so I forgot to go to my tap controller and actually add those sounds. So let's see, that's going to be on my bird. And I just need to drag in these audio source objects. So now I can play, and I shouldn't get any errors. Okay, so not like the sexiest sounds or anything, but I mean, we just made them in like 2 minutes. So what I do want to do is sort of even out the volumes. I think that bouncing audio is going to get really annoying really fast. So let's take the tap. Actually, I think I'm just going to bring all the volumes down. We don't want anything overshadowing any other audio. I'm just going to set them all to 0.3. See what that sounds like. The die one is actually okay. That's not really as high pitched. High pitched sounds tend to sound more annoying, especially if they're playing all the time. So I'll leave my die volume all the way up. That didn't sound too loud. My score volume is probably going to be the most annoying of all. Let's just play this, see what it sounds like. And I might actually make... I think I'll make my tap volume much lower. That shouldn't be the same volume as my score volume. So let's go to my tap, and I'll make that like 0.08. Pretty low. I'll reduce my die a little bit. Okay, let's try that. Oh no, I was in play mode. Crap, I hate when I do that. Okay, tap was 0.08. Die 0.8, and score, we can just leave that. Okay, let's run this. We're getting closer to publishing, so close. Okay, so that's tolerable. Yeah, I think that's pretty good actually. So I think I'm going to play this for a minute, see if I can find any additional bugs before we go into publishing. And I'll let you guys know what I find. I did find something already. If we look at those pipes, you can see that the colors are inverted because I rotated the top one by 180. So this is sort of picky, but this color should be on the same side as the bottom pipe. To fix that, I'm just going to scale the prefab for the pipe, the top pipe. The X just needs to be scaled negatively. So let's run that, and that should fix it. Okay, yeah, I think that's better. It is kind of picky, but you know, we want it to look good. And I think that I'm gonna make it a little bit easier. Those pipes are way too... Actually, you know, I think an easier way to do this, the pipes are pretty narrow. I'm just going to reduce the tap force, and that should make it easier. So I can be inside the pipe and tap without having to worry too much. That's pretty comfortable. And it's probably too easy. So I'll increase that. It was at 225. I'll just split the difference. I'll go whatever the difference is. 212. Good enough. Okay, so now we're going to get into publishing, talking a little bit about that. Okay, so I've done a little bit of looking around, and the problem is with publishing, this bird... Let me reduce my gizmo size. This bird is like some slightly older version of Twitter's icon. I was able to find it. It has this little fin on the top of his head. And I found some branding guidelines on Twitter. So these guidelines are basically saying that, we can't modify or even show this in the wrong color. I'm not even going to take a chance with it. It was on flat icon, and I'm surprised that it was under the selection group, because that implies that we can use it. It has the flat icon basic license. So I just found this bird. This was actually created by FreePic, and I think they're the main author on flat icon. So I'm going to credit FreePic for this one, and I'm going to download this sprite and use that as the main character in this game. So I'll go ahead and just click PNG. I'll download the 512, and I'll credit FreePic. And so before we publish, we have to make sure that we make our attribution within the game. So let's go back to Unity. So back in Unity, I'm going to open up my file explorer and find that bird that I just downloaded. And I'm going to replace that with the one that I'm using now. So in my downloads, we should have the bird somewhere in here. And I think it's a piece dove, blackbird maybe. So I'll drag that into my sprites. Okay, and I'm just going to switch those out. So I'll click my bird and I'll switch out that sprite. And I want to make sure I remember to enable generate bitmaps and border bitmaps. And I'll reduce the quality to 512, normal quality. And that'll get rid of the aliasing. I think he looks pretty cool as well, so I'm pretty happy with that change. Now I need to go in my start page and add a text component. I'm just gonna say let's duplicate this text, and then let's bring it up. So bring it up to here, and this text is just going to say, with help by FreePic at flaticon.com. I'll change that font. I think Sego is finally going to have a purpose. UIL is probably going to be good. Okay, so we'll see how that looks. I think that looks good. That's a good attribution right on the front. And this is a clone anyway. I'm not trying to take any creative responsibility for this game. I'm sorry, that's the wrong way to phrase that. I'm not trying to take any creative credit. Obviously, there's some responsibility with taking a Twitter logo, for instance. But yeah, I don't have any problem with giving attribution. I think it's definitely worth it. Now, I do want to make sure that my new bird has a good enough collider. It looks about the same. The size of the bird looks the same, so it doesn't look like we have to change too much there. Okay, so I'll go ahead and save that. And with regards to publishing, we can see pretty much all of our requirements in terms of getting it on the App Store or the Play Store from the Google Play Developer Console. If you haven't created an account, you need to do that. It's $25 a year, I think, unless they've changed that. So once you do that, we can take a look at the Play console. But with regard to Unity, we need to go to our build settings, make sure that we're in Android, add our open scenes. Let's go to Play settings and see something that we need to change. So we only want this to be in portrait mode. I'll get rid of the landscape options and the portrait upside down options. Everything else is pretty straightforward. I do need to add an icon, splash image. Yeah, let's go ahead and go through this really quickly. So their new splash image editor is pretty cool, and this might only be a Unity Plus feature. I'm not sure. So we can preview what the splash is going to look like. I'm honestly fine with that. I don't have a problem with that at all, so I'm not going to mess with it. Other settings. Now we need to change the company name. Ours is Renaissance Coders. And I'll put a space for Flappy Bird. That's what's going to actually show up on the Google Play store. We'll say com.rc.tappybird is our actual package name. and the version is 1.0, so that's fine. If we run into any issues uploading this, we can come back and change these settings if we need to. We do need to create a key store, so let's see if I can remember how to do this. It's been a while. So we need to click create new key store and create a password for that. I'm going to write that down so I don't forget it. So the key store is really important. You can't upload your game without the key store. And if you want to update your game, you have to use the same original key store that you used when you first uploaded it. So it's really important that you keep your key store. Correct me if I'm wrong on that, but that's been my experience. So make sure that you remember your password and all of that good stuff. Now there should be like a create new somewhere in here. Oh, so you click browse, browse key store, and then you can create your new key store. So that's the way it works. So I'll just call it user, that's the default value, and it's saving in my Flappy Bird, or it should be Tappy Bird, but my Flappy Bird folder. So notice the directory that it's saved in, and I'll just save it there. Now we can say create new key, okay, and we can fill out the alias. The alias can be whatever you want. I'll just call this RC developer. Password doesn't really matter. I'm sorry, it doesn't really need to be different than your key store password. It's up to you. But it can be different than your key store password. First and last name, I mean, all of this stuff, optional. You don't really need to do all that. So I can create key just like that. That'll create. And after that is finished creating, I should be able to see it as an option in this alias dropdown. Okay, so here we have RC developer. This is the key store that I just created. That's going to be what I have to use to upload to the Play Store. Okay, you will get an error if you try to upload without creating this key store, and that's basically what you have to do. You just have to create the new one, and then that option will show up. Add the password. You'll be good to go. So the only thing left to do really is art. So let's go over to the Play console and see what we have to do there. Okay, so now we're over in the Play console. You can really just Google the Google Play console, developer console. Like I said, or I don't know if I've said this yet, but I think it's about a $25 fee unless they've changed that. It's been a while since I looked into that. But this is what the front page is going to look like. It'll give you a list of your applications, and this has changed quite a bit since I was last on it. I've already created Tappy Bird, but if you want to create a new application, you just hit create new application, and that will pull up a fresh window with a column over here for all of your settings for that application. So I've already filled out the requirements for this application, but I'll go through and just basically talk about the minimum requirements to upload to the Google Play Store. So anywhere you see this blue star, that's going to be a requirement. So we just need a title, description, a short and a full description. Then you need to add some art. So you just need a minimum of 2 screenshots for the phone. You can also add screenshots optionally for different devices, but minimum requirement is 2 screenshots for the phone. Then you need a high-res icon, a feature graphic, and those are the only 2 graphics required beyond these screenshots. And it tells you the size requirements for those images. Then we come down. We have the option of adding a promotional video. We determine the application type, the category, and then it'll ask you right here to fill out a content rating. So that'll take you to a new page and ask you a series of questions, and then you just submit it, and it'll show up here. Now you have to upload your APK file. You get the APK from building the Unity project. Once you get that APK, you put that up in your app releases. I'll show you that in a second. But basically it'll tell you you can't do this until you upload your APK. You have the option of adding a website. You have to you're required to add an email for support, and then you can just determine whether or not you have a privacy policy right here. So really all you're concerned with, the minimum requirements, is filling out these 4 rows. So app releases, store listing, content rating, pricing, distribution. So let's look at our app releases. That's going to be where we actually add an APK. So here we have edit release, but you would normally just say manage production. You can also manage a beta file or an alpha file. For us, we don't need that. So we have a release that hasn't been rolled out. At this point, you would see the option for adding your APK file. If I hit edit release, then we can see upload APK. I already have an APK uploaded right here. You determine the version of your APK or your game, and then we can go to review. And from here, we can say start rollout to production. But this actually won't be an option that's available until we get these 3 green circles showing up. So we looked at store listing. Let's look at content rating. And this is going to be the page that you get brought to for your questionnaire. That's going to determine the rating of your app. And this is what's only available after you add the APK file. Pricing and distribution, determine if it's paid or free. There's some other requirements if you determine to make your, or if you decide to make your app paid. Obviously, you have to set up a merchant account. We're not going to do that for this game. Countries, you can determine which countries you want it to be available in. So it gives you full control over that. I'll just say it's available in all countries. And then you're really just looking for these blue stars. So these are the requirements. No, it doesn't have ads. You can determine if you want to add categories for the game. Accept the content guidelines and the US export laws. And that's it. So once you fill out all of that, you should get these 4 green check marks. And then we can go to app releases, edit release, review, and then start rollout to production. Okay, so that's it. I think we covered everything. This was a really long tutorial. And of course, ask your questions in the comment section below. And you know, if you didn't like it, if you didn't like this format, because this is definitely a different type of video, we haven't done this before. But if you like it, let us know and we can do some more. It definitely takes more time to do these types of tutorials. But if you didn't like it, let us know that too, so we don't waste time making these types of videos. But otherwise, I hope you guys have a great day. Thanks for watching, and I'll see you in the next tutorial.